Greetings, students. Here we are again, studying logic during a global pandemic. And you might be asking yourself, why exactly are we doing all this? Learning the truth tables, learning how to translate arguments into symbols. What's really the point, right? Well, as you know, philosophers are concerned with arguments, which I've said is a joint attempt to get at the truth. And symbolic logic is useful in helping us get clear on our arguments. Applying the formal techniques of logic to a vague argument can help us to clearly display all the parts of the argument, free it of vagueness and ambiguity, and help us see exactly what is being claimed or argued for. If sentences are translated into symbolic form, then the propositions, the meanings of the sentence become precisely displayed. And with precisely displayed sentences, it's much clearer whether the conclusion does or doesn't follow from the premises. In other words, if it's valid or not. And if the argument is valid, we can then begin to pay attention to the premises and see which ones we think are false or true. So we can decide exactly what it is we are disagreeing on if we dispute the truth of the conclusion. So symbolic logic can help us focus on what is important and what we're arguing about. Also, some philosophers believe that symbolic logic can reveal the structure of any possible good or valid inference, and in this way, it reveals the common structure that underlies all reasonable thought. Bertrand Russell, Ludwig Wittgenstein, and others have argued that there is a close connection among three things: logic, our mind, and the deep structure of the physical world. And the great logician Kurt Gödel was able to show us in the early years of the 20th century what the limits of logic are, using symbolic logic to let us know the things that human beings can and cannot know through formal sentences. He sort of made precise what Socrates was talking about when he claimed to know what he knew and know what he didn't know. Other thinkers interested in linguistics use the symbolic analysis of our natural language to try to reveal things about the character of language itself. For example, can all the grammatical sentences of English but none of the ungrammatical ones be generated mechanically by using a small number of symbolic rules? Can all the meaningful sentences of English, or German, or Dutch, or Finnish, or Tibetan, but none of the nonsensical ones be generated mechanically by using a small number of symbolic rules? Finally, symbolic logic can help us clarify the philosophically important concepts of meaning, truth, and proof. We can begin to think about what we mean by meaning. Symbolic logic is also of special interest to computer science, which is just symbolic logic implemented in electrical engineering, as we begin to talk about when we looked at the and, or, and not, and talked about how they could make little electrical circuits out of them. Computers are simply symbolic logic machines because their electric design follows basic principles of symbolic logic, and their programs are themselves based on principles of symbolic logic. In fact, the first programming language evolved from the language of classical symbolic logic, and an electrical engineer who designs digital computers creates the machine's gates and networks on its chips according to the principles of sentential logic, which is a part of symbolic, and symbolic is also used for simplifying complicated electrical circuits, using symbolic logic to create a simpler circuit that works the same as a more complicated one. Symbolic logic is also used in analyzing the theoretical limits of ideal digital computers to help us understand what computers can and cannot compute. And symbolic logic techniques are also used in automated reasoning programs that can create proofs of some statements and not simply check a proposed proof. And finally, symbolic logic is of special interest to mathematicians because predicate logic, which you would learn in the next logic course if you end up studying it with me, is capable of expressing every mathematical statement without significant loss of content. So the proofs and theorems of any field of mathematics can be translated into the proofs and theorems of logic. And when fields of mathematics are represented this way as part of logic, the logician can more clearly see the extent of that field of mathematics and make its assumptions or axioms clear. And also, after translating a mathematical theory into symbolic logic, it's much easier to establish the answer to such questions as, will this theory result in a contradiction? Or could there be a machine which could always correctly answer whether a given statement is a theorem of this theory? Now, that's a lot of cool stuff. But what it gets down to me, and what I do, is dealing with arguments and how to prove if they're valid or not. And it can simplify things enormously. Just consider the following. Suppose you know the following facts about Dr. Getch are true. Dr. G can join the Red-Headed League if and only if he has red hair. Look at that, I misspelled that. Let's fix it. If and only if he has red hair and is of Irish descent. Dr. G can't join the Red-Headed League, and Dr. G has red hair. Can we use these facts to prove that Dr. G is not of Irish descent? Well, we can use these facts to prove it, and we could do it like this. If it's true that Dr. G can join the Red-Haired League, if and only if he has red hair, whoa, let me jump up on the board there, that should be an if. If and only if he has red hair and is of Irish descent, then it's also true that if Dr. G can join the Red-Haired League, then both he has red hair and is of Irish descent, and that if he both has red hair and is of Irish descent, then he can join the Red-Headed League. But if that is true, then it's also true that if he is both red-headed and of Irish descent, then he can join the Red-Headed League. And if we know it is true that if he is both red-headed and of Irish descent, then he can join the Red-Headed League, and it is false that Dr. G can join the Red-Headed League, then it must be true that it is false that he is both red-headed and of Irish descent. And if it is true that it is false that he is both red-headed and of Irish descent, then it's also true that either he's not red-headed or he is not of Irish descent. And if it's true that he has red hair, then it is false that he does not have red hair. And if it is false that he does not have red hair, and either he does not have red hair or is not of Irish descent, then we may conclude with certainty that Dr. G is not of Irish descent. Lordy, but there might be a simpler way to go about this. If we let R stand for Dr. G has red hair, J stand for Dr. G can join the Red-Headed League, and I for Dr. G is of Irish descent, then here's our argument, here's our premises, premise 1, premise 2, and premise 3, and there's our conclusion, right? If Dr. G can join the Red-Headed League if and only if he has red hair and is of Irish descent, and Dr. J cannot join the Red-Headed League, and Dr. G has red hair, then Dr. G is not of Irish descent, and we could prove it using techniques we will learn in the next few weeks. And this, to me, looks a heck of a lot easier than that long-winded thing I went through in the English language. But to get to where we can do what I just showed you, we have to learn to translate out of our natural language, whether English, German, Finnish, Tibetan, Norwegian, Spanish, whatever your language is. Right now we're using English, into symbols. And we'll begin with very basic translations and work our way up to where we can simply handle any argument we're given to put it into symbolic form. So we start with the not. And there's our truth table definition, which shows us what it means. And it's translated, and these are called negations, and it's we use the symbol called the tilde to translate not in its stylistic variants. Stylistic variants means the different ways it could be expressed. Remember, things could be expressed many different ways in English, and yet they're still going to mean the same thing. If I said Darth Maul is not a Jedi, Darth Maul isn't a Jedi, it's false that Darth Maul is a Jedi, it's not true that Darth Maul is a Jedi, all of that would be symbolized as not J. And is called a conjunction. And we used the symbol, the ampersand, to translate and along with its stylistic variants. Consider, Bilbo had a second breakfast and Gandalf had a cup of tea. We let B stand for Bilbo had a second breakfast, G for Gandalf had a cup of tea, and that gives us B ampersand G. Now our stylistic variants begin to grow on us with the and. Right? And in English can have a lot of different meanings, but all we're interested in is the one we saw in the truth table, or we remember from the electrical circuit. It's only true when both of them are true. And so when we're translating and or its stylistic variants, we'll always use that ampersand. So Bilbo had a second breakfast, but Gandalf had a cup of tea. That's the ampersand. Bilbo had a second breakfast, however Gandalf had a cup of tea. Bilbo had a second breakfast while Gandalf had a cup of tea. Although Bilbo had a second breakfast, comma, Gandalf had a cup of tea. Bilbo had a second breakfast, yet Gandalf had a cup of tea. Bilbo had a second breakfast. Nevertheless, Gandalf had a cup of tea. Bilbo had a second breakfast even though Gandalf had a cup of tea. Bilbo had a second breakfast though Gandalf had a cup of tea. All of these, right, all of these might have different kinds of overtones or senses in English, but we're not interested in those. We're only interested in the core logical meaning. Also, don't let the English forms fool you, right? For example, consider John and Bob are married, or Sarah and Jane are friends. It looks like you'd want to say there's an and there joining them, but don't let the surface language fool you. We're looking for the propositional meaning. And propositions like this usually indicate a relationship that John and, not K, John has a different orientation. John and Bob are married to each other, right? Sarah and Jane are friends with each other. So we'd let M stand for John and Bob are married and translate it with an M, and Sarah and Jane are friends and translate that with an F. And here's or, our other major connective, or one of our other major connectives, which is only false when both are false. And we say we're translating disjunctions, and the symbol V is used to symbolize or and its stylistic variants. For example, either Bilbo had a second breakfast or Gandalf had a cup of tea. Bilbo had a second breakfast or Gandalf had a cup of tea. Or notice this one. Bilbo had a second breakfast unless Gandalf had a cup of tea. All of these would be translated as B, V, G. So whenever you're translating and you see an unless, in your mind you can just think, I just put a V there. And you'll remember how to translate it. Now it's important to realize that in the English language, or can have two senses. There can be what's called an inclusive or, and that's the or translated by our truth table, either A or B or both, or what's called an exclusive or, either A or B, but not both. And we don't often run into this explicitly spelled out, except for in legal documents. But if you're sitting at my table and I say, you can have salt or pepper on your eggs, I mean, you can have one or the other, or both, right? And that's inclusive, right? But suppose I said, either the Empire or the rebels won the Battle of Yavin 4, right? Well, they can't both have won the battle. It can't be true both that the Empire won it and the rebels won it would equal true. So this is a different kind of or, and we translate it in a different way. We would say, either the Empire won the Battle of Yavin 4, or the rebels won the Battle of Yavin 4, and it's not the case that they both won it. So that's how we express the exclusive or in our symbolization. Remember the meaning of the conditional, or the if then. It's only false when you have a true antecedent and a false conclusion. And in translating conditionals, we use the symbol, the arrow, to symbolize not or, look at that, to symbolize if then, and its stylistic variants. So if we said, if Qui-Gon goes to Tatooine, then he will meet Anakin. We let T stand for Qui-Gon goes to Tatooine, and A for Qui-Gon meets Anakin. Then that gives us if T, then M, or T, therefore M, or T implies M. Now, there's a lot of different ways to express if T, then M in English, and you want to begin to study them very carefully, right? If you don't learn how to translate, you can't continue in this course, because that's the whole point, to take arguments in English and translate them into symbols. So this is something you're going to be studying for the rest of the semester and going to be using over and over again. So it has to be a skill you pick up and develop, right? So look at these examples, and you might want to think about making flashcards for yourself. On one side would be the English, on the other side the correct translation. You could flip it and test yourself on it. I know it's a lot of work, but welcome to college. So, if Qui-Gon goes to Tatooine, then Qui-Gon meets Anakin. Now look at this one. Qui-Gon meets Anakin if Qui-Gon goes to Tatooine means if Qui-Gon goes to Tatooine, then Qui-Gon meets Anakin. So that would be translated as if T, then M. But Qui-Gon goes to Tatooine only if Qui-Gon meets Anakin. Well, that's if T, then M. So don't confuse an if by itself, right? Looks like we got an if by itself there. Don't confuse that with only if. We could say, given that Qui-Gon goes to Tatooine, Qui-Gon meets Anakin. Given that, this means if. And then there it is in the middle again. Qui-Gon meets Anakin, given that Qui-Gon goes to Tatooine, which means, given that Qui-Gon goes to Tatooine, then Qui-Gon meets Anakin. Similarly, assuming that is like an if, right? Assuming that Qui-Gon goes to Tatooine, Qui-Gon meets Anakin. If T, then M. Okay. Qui-Gon meets Anakin, assuming that Qui-Gon goes to Tatooine, because that means if Qui-Gon goes to Tatooine, then Qui-Gon meets Anakin. Provided that, that's just like an if too, right? Provided that Qui-Gon goes to Tatooine, Qui-Gon meets Anakin. If T, then M. And there, if we put that if by itself in the middle, provided that just means if, it's going to turn to if T, then M as well. You just have to sort of settle down and study these patterns and memorize them. So let's think about if then a little more. Note well, in a conditional statement, an if precedes the antecedent of the conditional, while an only if precedes the consequent. Right? You want to pay attention to this because students often confuse it, and you don't want to confuse it so you don't lose points on your exam, first of all, and secondly, just so you can understand what the hell's going on when you read something so you know what it really means. Because that's why you came to college, to get educated. Right? So an if by itself, what I think of as a lonely if, precedes the antecedent of the conditional, while an only if precedes the consequent. Consider, you're a hobbit, H. L, you love second breakfast. If you are a hobbit, then you love second breakfast. And if precedes the antecedent. And this is the antecedent, so this would be translated as if H, then L. But only if you're a hobbit, you love second breakfast. The only if precedes the consequent. So what follows the only if goes into the consequent, and that becomes if L, then H. And if I said, you love second breakfast if you are a hobbit, and if precedes the antecedent. So if you're a hobbit, then you love second breakfast. If H, then L. Or, you love second breakfast only if you're a hobbit. That just means if you love second breakfast, then you're a hobbit, because the only if precedes the consequent. So this is in your textbook, and you want to study this carefully, and certainly you want to make like 4 flashcards for yourself here, or however you do this, right? But you need to know these patterns, and I promise you, this will be on the next exam, and you don't want to lose about 16 points here or something off an exam just because you didn't study these patterns. But besides memorizing it, we want to sort of develop our logical intuitions and think about it. So suppose someone said you were in Florida if you are at Eckerd College, which means if you're at Eckerd College, then you're in Florida, as opposed to you are in Florida only if you are at Eckerd College, which would mean if you're in Florida, then you're at Eckerd College, which is a silly thought, right? The logical meaning of these two propositions is very different. You're in Florida if you're at Eckerd College means if you're at Eckerd, then you're in Florida. But you're in Florida only if you're at Eckerd College means if you're in Florida, you're at Eckerd College, which is crazy because you might be in Miami or Jacksonville or anywhere in between, or you might even go to Key West. Then we have if and only if, or the biconditional, whose meaning is when both are true, it's true. When the truth values are different, it's false. When the values are the same, false is the same as false, it's true. Right? And we use our double arrow. Luke will become a Jedi if and only if he faces Vader. J, double arrow, V. Now let's explore a few details. Let's think first about the scope and meaning of negations. Consider the difference between the negation of F and P and the conjunction of not F and P. And notice how I talked about that. You need to learn to understand the language, right? This is the negation of the conjunction of F and P. This is the conjunction of the negation of F and P. So we let F stand for you failed the exam, P you've passed the exam, right? And this means it is false that you both failed and passed, which would be crazy. You can't both fail and pass the same exam, as opposed to you did not fail, but you passed, right? They mean very different things. Consider some other examples. If we let G stand for Galadriel takes the ring, and T, Galadriel is tempted to take the ring, if we negated the disjunction of G or T, right, it's not the case that Galadriel takes the ring or is tempted to take it, which would mean something very different from Galadriel doesn't take the ring or she is tempted to take it. Or suppose we said, letting T stand for Socrates teaches philosophy and R, Socrates will be respected, the negation of if T then R is very different from if not T then R. So this would be, it's not true that if Socrates teaches philosophy, then he will be respected, which doesn't mean the same as if Socrates does not teach philosophy, then he will be respected. That would mean something very different. And even more delightful details to amuse you this morning, evening, or middle of the night, whatever you're doing, wherever you are. Let's think about the great Augustus de Morgan. There's my man, Augustus de Morgan, who lived from 1806 to 1871 and was a noted English logician and mathematician who came up with what are called De Morgan's laws. And by the way, this little, see these four little dots, that means is logically equivalent to. In logic, you'd think, why don't you just put equals there? Well, equals comes to mean something very specific when you move into next level logic, and so we want to always use our symbols like we should use them. So we don't use the equal sign here, but we use this little symbol, which means it's logically equivalent to. And you should memorize these with examples and make flashcards of them. The negation of P or Q means the same thing as the negation of P and the negation of Q. Now, at this very minute, you can take my word for that, but in about 3 weeks, you'll be able to prove it. How about that? And the negation of P and Q is logically equivalent to the disjunction of not P or not Q. So the negation of a disjunction is logically equivalent to the conjunction of two negations. And the negation of a conjunction is logically equivalent to the disjunction of two negations. How about that? So we want to get down into the weeds, as it were, of normal everyday statements and arguments and see how we can apply De Morgan's laws to translate things in different ways that yet mean the same thing. And it can sort of help you understand what people are really saying. So suppose you're hanging out in the caf, properly socially distanced, of course, and you hear somebody mumble through their mask from 6 feet away. You can skip the final exam and you can pass the course, which could be symbolized as S ampersand P, right? But luckily, your professor is passing by 6 feet away from all three of you, and he overhears that fool mumbling that through his mask, though he's only a fool about exams, because obviously he's a bright fellow, he's wearing a mask, and the professor says, no, you can't both skip the final exam and pass the course. That's just not going to happen. I've set the grading system up so that if you fail the final exam with a 0, you won't pass. All right? We could symbolize not both as a disjunction of a negation. You can't both skip the final exam and pass the course has the logical meaning of either you can't skip the exam or you can't pass the course. Right? And so that's one way to translate that. Right? Not P and Q. It's the same as not P or not Q. And on an exam, just to see if I understand that you understand that I understand that you understand De Morgan's laws, I might give you a statement like, you can't both skip the final exam and pass the course, and ask you to translate it in 2 ways. And I might even put a picture of Augustus there to cheer you up and inspire you. In English, we'll also run across this phrase neither nor, and we can translate neither nor 2 ways as well. We could translate it as a conjunction of a negation. Oh, look, my spelling's off there. Let me jump up to the board. Conjunction of a negation. Suppose I'm eating in the caf and they have some sort of dish I'm trying. Who knows what it is? But I taste it and I say to myself, I will neither eat this, you set your fork down, nor will I recommend it to my friends. Now, logically this means I will not either eat this or recommend it to my friends. In other words, it's not the case that I'm going to either eat it or recommend it to my friends. I think I'll just go get an apple and forget about it. But a neither nor could also be understood as a negation of a conjunction. If I say I will neither eat this nor will I recommend it to my friends, it basically means I'm not going to eat this and I'm not going to recommend it to my friends. So essentially, the negation of P or Q is equivalent to not P and not Q, and not P and not Q is equivalent to the negation of P or Q. The little logical symbol means you can go from this to this, or from this to this, and the logical meaning doesn't change. Again, you have to take my word for it, but only for about 3 or 4 weeks. In 3 or 4 weeks, you'll be able to prove that this is true. And finally, for this pandemic video session, which I reach out to you through my mighty YouTube empire to continue to instruct you in logic, even though I'm quarantined in my house, right? Let's shed a tear. I hate being quarantined in my house and not being with you. But it's fun to think about unless, nonetheless. So let's think about unless a little bit more. Let's let F stand for Frodo's quest will fail, S for Sam helps Frodo. So suppose we thought, Frodo's quest will fail unless Sam helps him. Well, one way we've learned to translate this, I said, is just put a V there where the unless is, because what that really means is either Frodo's quest will fail or Sam helps Frodo. Right? Remember, the him has to turn to the Frodo. Right? But it turns out that F or S also means this. Frodo's quest will fail unless Sam helps him means the same thing as Frodo's quest will fail if Sam does not help Frodo. Which means, as we know, because what follows the if is the antecedent, if Sam does not help Frodo, then Frodo's quest will fail, giving us not S, then F. And this has the same logical meaning, and you'll learn how to prove that again in a few weeks. In general, P or Q can become not Q, then P. Right? Consider, either Vader returns to the Jedi or Luke dies. Right? We let V stand for Vader returns to the Jedi, and L stand for Luke dies. And we would translate that as V or L, P or Q, but we could turn it into not Q, then P, which would make it, if Luke doesn't die, then Vader returns to the Jedi. And indeed, we saw the return of the Jedi in that great documentary made about those historical events in a galaxy far, far away, where we saw that when Vader saw the Emperor killing his son, he returned to the Jedi. The Jedi returned. We saw the return of the Jedi, Anakin Skywalker. And Darth Vader became Anakin Skywalker, and threw that bastard Palpatine right down the power shaft into the reactor and killed his evil ass. Ta-da! And Luke was saved, and the galaxy was saved, and Anakin Skywalker was a Jedi once more, though sadly he died and became one with the Force. But he redeemed himself, and Luke went on to become the greatest Jedi that there ever was. And that's another logical lesson for you today. So I'll be coming at you real soon with another video on the intricacies and wonders of the language of symbolic logic. Thank you for your kind attention.